Okay, I think it's recording. Okay. Anyhow, for numbers 1, 2, 3, and 4, as I mentioned, what you want to do is find the remainder when you divide the exponent by 4. If there's no remainder, you assume it's just 1, right? Because there's a pattern that goes with this. Remember, the pattern was this: I to the 1 power is I squared is -1, I cubed is -I 4 is back to +1. And it's just like this. That's just what happened. I -1, I squared is -1, I cubed is I squared times I, which is -1 times I, or -5. I4 is I squared, -1 is +1. And then it just repeats. So like in this case, you break it down this way, just ask yourself, what's the remainder minus by 4 is 2. It's just like I squared is -1. What's this remainder divide that by 4? That's 3. So it's like I3, so it's -1. That's remainder of 1, that's I, that's the remainder of 3 again, -1. So that's the best way to handle those without a calculator. But if you do have a calculator, and actually I'll pull it up because I might need it for today's lesson. Math department, Rabbit EMU, browse, or erase.
All right.
Finish. Yeah, so if you so desire, you could also just do, second that raised to the 45 power. Liam, you might close the door, please? Or yeah, thanks. Yeah, the only thing that's kind of weird is that it does a scientific notation. It just means 0 plus I. I don't know why the algorithm does that in the calculator. Don't worry about it. But anyway, we'll move on. So here, that's just combined like terms or distributing. If you have to distribute, not that bad. Those are the answers there. These are open school, all the answer keys. And by the way, the packet I gave you is actually not for the entire unit. This will take us to probably Spirit Week, which is in a couple weeks. There's still more, so this is a really meaty unit. So I'll give you guys more materials when the time comes, but just get it's not the whole unit. This is actually even more stuff we have to do. 8, 9, 10 is right here, just distributing or combining like terms. If there's minus, make sure you distribute the minus. 11 is distributing, but distributing I. 12 and 13 are foiling. 14 is a FOIL situation as well as 15. 16, 17. Any questions on these? I know, but they're kind of fast. Any questions? We're good? We're good? Okay. 16, 17 is division. Now, if you see a plain old I in the bottom, see a single term that's imaginary, use full by thumb blah. You can ignore it if you want, but you have to simply ignore it afterwards. But you don't have to do a conjugate here, so only one term. Whereas 2 terms with the imaginary, then you have to do the conjugate, which is 1 minus, right? You got to do both top bottom for fair treatment, and then you got to go through the motions and FOIL and distribute and simplify afterwards. These fractions should be broken down. I'm not sure why they're not broken down, but like for example, I would much prefer that you write 18 as -4/3 minus 2/3 I. I'd much prefer you do that. There's 19 right there. There's 20 and 21. Yeah. So, questions? We good? Cool.
Oh, wait, actually, I did.
Yeah, good.
Can we go over number 6?
6, no problem. Let's just combine like terms. Just be careful. -I plus 7 minus 5i, -6 plus 9i. And then you just continue combining like terms, which should be +3i and +1. So 1 plus 3i.
Yeah, I'm also distributed
Right, which is -6. Then you got to do -3 times -3i, which is +9i. Multiply what?
parentheses.
Oh, so you did something you weren't supposed to do. Got it. No worries. It happens. Okay. All right. This was pretty straightforward. So I think we can close the book on that. All right. So let's talk about 7.2. So you want to get out the notes packet. Now, I accidentally photocopied the homework with the notes packet for 7.2. So don't be alarmed when you see so many pages for it. It's actually supposed to be just 4 pages for the notes, not homework 41 is supposed to be in the separate homework packet. So don't worry, we're not doing 9 pages of notes, just doing 4 pages of notes. So let's get started from the top here. All right.
And we're still recording, right? Good. Okay. So key components of quadratic functions. It's all about quadratic functions. So it's all kind of review. So a quadratic function standard form is that ax squared plus bx plus c. You should know that. Should be reviewed from last year. We did quadratic functions in algebra 2. We call it parabola. Parabolas have symmetry. The vertex is a high or low point because they could open down too, right? It could be like a round face. But the vertex represents a high or low or the extreme point. There will be a y-intercept. The domain's all real numbers, so there will be a y-intercept. You can plug in 0 for x, not a problem. The axis symmetry is a formula that goes with this negative b over 2a. And to find the y-coordinate of the vertex, sorry, the axis symmetry is x equals negative b over 2a, which is also the x-coordinate of the vertex, because the vertex fits on the axis symmetry because it cuts in half. To find the y-coordinate of the vertex, you plug in negative b over 2a back into the original equation. That's why you see f of negative b over 2a down below. Now, you can memorize it because, sometimes people forget, like, wait, was it an A, is it a B, is it a 2, is it a negative? Like, sometimes some people forget this formula. Does anyone know why that's the axis symmetry, like where that comes from? Where does that negative b over 2a come from? Or what do you think it looks close to that you've seen before many times in algebra 1 or middle school math? What am I writing right now? Quadratic formula, right? Good. Well, what does the quadratic formula tell us? What does it provide? What information do we get from it? Graphically speaking, mind you. Remember, x equals this, right? So remember, you have an equation. Say you have an equation like this, 2x squared minus 5x plus 1. Well, originally, let's say you have this, y equals 2x squared minus 5x plus 1. Let's say originally you have that, right? I know it's kind of hard to read. But let's say you have y equals 2x squared minus 5x plus 1. You replace y with 0. When y is 0, where are you on the coordinate plane? Where does y equal 0 on the coordinate plane? X-axis, good. So these are x-intercepts, right? The quadratic formula provides x-intercepts because you're deliberately replacing y with 0, and then you're using it to solve the equation. So this is what happens when you set y equals 0. You get the quad form. If you actually were to go through completing the square, which I know you guys done, actually go through the formal proof, you would stumble upon this formula. This is really the formula. It's not something just fell sky. Actually, there's a process you have to do to complete the square together. But anyway, we have the formula, right? So those are x-intercepts. Well, when you have x-intercepts, let's think about it. When you have x-intercepts, you have 2 dots right here, right? And you have a parabola that goes through it. If it's a parabola, right? Well, think about it. I'll call this x1. I'll call this x2. Wouldn't x1 just be negative b minus the radical, right? Wouldn't just because there's 2 answers, right? And wouldn't x2 just be this? Negative b plus the radical? What happens if I average these two?
If I add these two fractions, what happens to the radicals? The negative radical and the positive radical. They cancel, right? Just think about it.
What if this were like, say, forget calling this x1. What if this were like 2 and it's like 6? What's the axis symmetry here? If you have 2 and 6 as your x-intercepts, what's right smack in the middle? That's the average. What's average 2 and 6? 4, right? That's precisely what's happening here. If you average these two, I'm gonna have negative 2b, but the radicals just go away. Divide by 2a because you're having the LCD for the fraction. But because you're averaging it, you got to divide it by 2. These 2's cancel, but a 2 in the bottom comes back into the mix. You get negative b over 2a. That's where it comes from. It's the average of the solutions from the quad form, because the axis symmetry is the average. It's in between. That's where it comes from. So hopefully you just remember it now. It's just part of the quad form, just a very special case where we're averaging the x-intercepts and then we stumble upon that. So again, it's not some magic. There's a rhyme or reason to it. All right, get off my soapbox. Let's do some problems. Find the x-intercept, y-intercept, x-symmetry, vertex, blah, 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 min, max, domain range, all these things. Okay. What I would, shoot, I was hoping this is factorable. Crap, it's not. Well, I am going to use Desmos because this is not factorable. I thought this was factorable and that's lame. So let's go to Desmos. Desmos is our friend. Okay, so y equals 2x squared plus 4x minus 3. So you get these really nasty numbers, so be it. Okay, so we get those numbers there, right? And the y-intercept, that's what does this is nice because it just tells you everything. Just click a dot, So let's fill it out. So let's see here. 0, 3. X equals -1. -1, comma, -5. That is a min. The min's going to be all real numbers always for parabolas. The range is from -5 to infinity because it goes up. Low point -5. Oh, 0, -3. My bad. Why did I write 3? That was dumb. My apologies. Correct me if I make those mistakes, please. And then the x-intercepts, which my short-term memory doesn't serve me well. 5.81, 0.581, because that was not factorable, of course, and -2.581. There you go. Does that make sense? Right? Small review.
Think about it. Domains all go, who cares? Put where reference range is limited. You have a low point, high point. If it opens down, you have a max, right? So that's in min, of course. The vertex is in min. Yeah, and unfortunately, it's not factorable, so we had to use that.
Calculator Desmos. I mean, you use quad form, I suppose. I don't care, but just use technology, make your life easier. So if you use Desmos for your homework, it's totally fine. I don't care. But I want to make sure you guys can analyze it correctly. Now, this is probably a more advantageous form for graphing, the vertex form. Because the vertex form, you can immediately extract the vertex, right? You don't have to do the whole negative b over 2a nonsense. Actually, I didn't do it for this one. I should have. Coming back to this again, -4 over 2 times 2. Remember, it's -1, then plug in -1, you get -5, but whatever. I just use that as But remember, h and k is going to be the vertex. X equals h to the axis of symmetry. There's a negative out in front, so it opens down. The a is still the same it's still the same a in the standard form, still the same a value if you were to expand it. Still same thing, so it's still a parabola. Let's do it. Now this case, I don't know if we need to use Desmos. I think we can figure this out. What's my vertex, guys? You should know this. 4, 2. Yeah, and it's a bit tricky. The x minus, actually, it's counterintuitive. You want to say -4 for the x squared in the vertex. It's actually +4.
Because you have to plug 4 in to kind of get it back to the original, to get it back to the parent. So that's actually kind of counterintuitive. So it's actually 4 not -4, but that's intuitive. You want up 2, so up 2 for the vertex, right?
That is going to be a max, actually, because it's going to be opening down. It's going to be a max. If I plug in 0 for x, that one's going to be a little crazy. You get -30. Oh boy. Just go with it. Kind of crazy, right? Yeah, that's my y-intercept. X equals 4. Range is the high point's 2. It goes down forever. Yeah, it goes down forever, right? X-intercept, we're going to replace y with 0. No, I didn't. What did I do it in the wrong place in the?
Well, I don't know.
Okay, no, not at all. Oh, +2. There's a +2. Square root both sides. Where are my x-intercepts, guys? 3 and 5. Perfect. Thank you, Jack. 3 and 5. So the graph is going to kind of look something kind of like this. Sometimes you have to kind of sort of just do an estimate. It's a little hard to do it accurately. And we totally have a max, right? Yeah, I don't have to use, it was pretty easy to figure out the x-intercepts. It takes a little work, but just replace y with 0 and solve algebraically, if you can. If I have just quad form or your back book stuff, Desmos is fine, I guess. So questions? We're okay. Okay, so this is a fall review. Fall review. I'm not going to do anything too crazy with this. Well, these problems to get a little crazy. Given the two exponents, find two different quadratic functions, one opening up, one opening down. Okay, fair enough. So we have 4, 0, -8, 0. So what's the axis symmetry? I think that's important. We do that first. Axis symmetry, guys. What's halfway between -8 and 4? -2. Yeah, no, I mean it's 6 away from each, right? You're right. You're correct there. Okay. Okay. X equals -2. Okay. Then I don't know where the vertex is exactly. I mean, do we know where the y-coordinate vertex? We don't, right? So it tells me it's open-ended. You kind of choose where you want to put it. It's up to you, really. I don't know. Let's put it right here. Why not? Okay. So what would that equation be? Y equals a x plus 2 squared minus 5. How would I solve for a? How can I solve for a, guys? So what we could do is plug this in for x and y and solve for a. You can use either x-intercept, your choice. If you do that, 5 equals 36a. A is 5 out of 36. So your equation is y equals 5 out of 36 x plus 2 squared minus 5. Could I put it somewhere else? Sure. What may I put it right here? I could easily do that. That could work. In that case, I think hold on a sec. You get -5 out of 36, right? So the green would be y equals -5. I mean, trust me, if you want to work it out, but I'm pretty sure that's it. So yeah, it's kind of open-ended. It's kind of up to you how you want to do it. But to solve for a, you have to use one of the points given to you. Like one of the solve for that's what it's made here in obvious. That's what you do. I just write the vertex one because it's just more advantageous. And if you want to put a standard form, go ahead, just take on there. Vertex, these are intercept form. I guess you could have done that too, like x plus 4 times x minus, sorry. X minus 4 times x plus 8. Still solve for a, because you could have also started by doing this too. Y equals a. I call it P and Q for the x-intercepts. You could have done that, but that's all right. Questions at all? No? Okay. Let's keep moving. We got a word problem here, and then we got a couple more where problems are done. Okay. So the Little League Bruisers use the baseball throwing machine to help train the 10-year-old players, catch pop-ups, launch baseball with initial velocity of 48, height of 3.5. Anyone taking physics, by the way? Yeah, you probably have seen some stuff like this, but don't worry, we'll give you the form. You don't have to memorize it. But this is the form for projectile motion. And this is in feet per second. So the negative 16 is actually going to be the acceleration due to gravity in feet per second squared, where most of the time you guys use 9.8, right, for meters per second squared. But find the equation that models it. That's easy. You're already given all the details, right? Negative 16t squared plus 48t plus 3.5. Okay. That's easy. The next one is, what is the maximum height? How many seconds will it take to reach that height? Okay, well, here's what you do. The max height is a vertex. So what is the max height? That's going to be k. How many seconds will it take to reach that height? That's going to be h. So what you need to do is you need to find the x coordinate. I'm not going to use vertex form necessarily. Let's just do negative b over 2a. I think it's better for us. So you get 1.5. I need a calculator. Let me get So you get 39.5. So that's the max height. And it takes 1.5 seconds. Does that make sense, right? Because just draw a diagram if it helps, right? It starts at 3.5. Maybe because if you think about it, you're
not really the baseball. You play baseball, right? You play tennis. Yeah. But if you're a baseball player, I'm not with that, right? But you can hit the ball. I'm what, 5 feet, 5'8", or 3.5 feet is probably when I make contact with the ball, and it goes up in the air, right? And it takes about 1.5 seconds to hit the top of the peak, and then it comes back down to catch the shortstop or second baseman catches it, right? So it takes 1.56 seconds. And it hits its peak at 39.5. So that helps, hopefully. Hopefully that helps. That's I'm sure I started. But hope that helps. And you see, oh yeah, okay. That was great. We all this. We all that. Questions? Okay. We're good. Cool. All right. Almost done. I know it's been a long day for you guys. Well, you did have a late start, so don't feel so bad for you guys. All right. Okay, let's move on. Now these are a little strange. These are not as it's a little hard to visualize. Actually, you can't really visualize exam 5. But let's think about it analytically, and I think we'll be okay. Among all pairs of numbers whose sum is 20, find a pair's product is as large as possible. What does product mean again? What do you do when you do find a product? Multiply, right? So I'm going to think of the two numbers as x plus y equals 20, or it will be 10. You are correct, actually. Y equals 20 minus x. So when you want a product, that's x times y. I'll call it capital P for product. I'm going to replace y with 20 minus x. And I wind up getting an equation, right? But if you think about it, I could approach this graphically.
So yeah, whereas like, or you could do negative b over 2a. It's totally up to you, whatever you guys want to do.
Would it always be like
Yeah, 100%, 100% of the time. It's all about symmetry, right? So yeah, it totally happens at 10, and then the product would be 10 times 10 or 100. So your pair of numbers are 10 and 10. And the maximum product's 100. We're okay? It's good? Okay. Last one. You have 50 yards of fencing to enclose a rectangular region, find dimensions that may maximize the area. Okay, so here's your fence. We'll call this like Y and X. So if you have 50 yards of fencing, that's perimeter. Which I know is 2x plus 2y, or 50, or x plus y equals 25, or y equals 25 minus x. What do they want in the problem? What is it they're interested in? Maximizing what, guys? Area. So x times y. So x times okay. Remember, these are x-intercepts. It looks like this. Where do you think the vertex is going to be? Yeah. Notice how I'm taking a graphical approach to really make more sense of this. If you want, you could totally do this, negative x squared plus 25x, and do x equals negative b over 2a. If you want, you could do that. Go ahead. But personally,
If I have an array of factors, one is to find the x-intercepts, right? And just find the middle. I think that's easier personally. But if you want to expand it, and do negative b over 2a, go ahead.
I don't care, but I think it's better to graph it and find the x squared in the vertex. So now you know what happens at 12.5. So the dimensions are easy now. It would be a square that does maximize the area. Yes, 100% correct. Doesn't matter. A square is a rectangle, special rectangle. Doesn't matter. That's all geometry, right? And it's been a couple years. And your area, whatever 12.5 times 12.5 is, $156.25. Square yards. You should give the units also. Yes, a square does actually maximize the area. And actually, if you will revisit this in calculus. It's called optimization, where you actually use calculus principles to actually prove why a square actually does that. Like, how come other combinations doesn't work? There's actually a calculus kind of analytical solution that kind of helps you with that. So, but yeah, a square would do that for sure. Okay, so the homework is right here. So the beginning is just matching. That should be pretty easy. Then find the equation. That's not hard. The answers are up in school, by the way. Then this is a comparison to what we did in the notes, 11 through 14. More matching. Then some word problems. Yeah, it's quite a bit. So take advantage of the time. We still have a half hour, I think. We got 2:40, 2:45. It's 25 minutes. Yeah, I've been actually, all my classes have been doing my lessons in 35 minutes and giving it 25 minutes. So been actually consistent with all my classes today. All right, anyway, we'll stop and we're good.